So I'm coming back to another video here where I prepare for my fantastic new job on the 25th by by making myself as ready to go on day one as I possibly can. So there's the last video I uploaded. Last video we got through the Paramiku module, or at least we got through yeah, so I bookmarked this. So actually we didn't get through it all. We got through the first example, but now we're going to learn how to use Paramiku to configure a server. So where we left off last video, I was setting up a server for us to configure. So let's set that up. Looks like I can't log into it for some reason. Yeah, I'm not sure why I can't log into this. Screen refresh. 12 delete. Is there anything I can do? There's nothing I can do. What if I open it again? Here we go. Perfect. All right, so now we've got this second server. We've got plenty of interfaces on there. So let's keep going. So Paramiku can be used to manage servers through SSHv2 as well. Let's look at an example of how we can use Paramiku to manage servers. We will use key-based authentication for the SSHv2 session. In this example, I used another Ubuntu virtual machine on the same hypervisor as the destination server. You can also use a server on the viral simulator or an instance in one of the public cloud providers such as Amazon, AWS, EC2. We will generate a public-private key pair for our Paramiku host, which is going to be this new one here that we have created. So I've got to shrink it down. There we go. So let's open up a terminal lines and enter in that command, ssh keygen-t rsa. Oh, I did -r, not -t. So hopefully that won't make a big difference. So this command by default will generate a public key named id_rsa.pub as the public key under the user home directory home/.ssh, along with a private key named id.rsa. Treat the private key with the same attention as you would private passwords that you do not want to share with anybody else. So this is kind of a thumbs up for this book. Oops, and I forgot to share my screen, so I will do that now. But kind of a thumbs up for this book is that it's talking about this public key authentication, which is definitely the way to go. In just about every case you can go with it. You can think of the public key as a business card that identifies who you are. Using the private and public keys, the message will be encrypted by your private key locally and decrypted by the remote host using the public key. We should copy the public key to the remote host. In production, we can do this via an out-of-band using a USB drive. In our lab, we can simply copy the public key to the remote host's authorized key file, open up a terminal window for the remote server so you can paste in the public key. So they don't have a IP address set up yet. I'm not sure. Oh, okay, so it looks like here's the IP addressing that we're using. So you're now ready to use Paramiku to manage the remote host. Notice in this example, we'll be using the private key for authentication, as well as the exec_command method for sending commands, even though they literally just said in the last example not to use that. So that's kind of upsetting. Don't think it's worth a second strike, but I'm getting to the point where I might want to give this book a second strike pretty soon. So let's see here. Cat / yeah, so let's set this up. We're going to do connect 192.168.9.182 from this side, so we know that's going to be the IP address on this server that we're going to need. So looks like we're going to have to reopen it because it has gracefully closed. So we'll just need to log back in. GNS3 is the password, just the default password for this GNS VM. So we're going to need to put that IP address on there. And it's going to be on ENS6. And it looks like it's going to be 192.168.199.182. And let's use a /24. We won't need a gateway because we're just going to use this for management across the link. Another kind of upsetting thing about this book is that it talks about a lot of scenarios that you'll never ever encounter in the real world. And that's something I've been bringing up, kind of that unicorn environment. But it seems like they're doing that not just for the people you might meet and the situations you might find yourself in, they're also doing it at a technology level as well. All right, so let's see here. Copy the contents. So paste it into that. We're ready to use it to manage the remote host. Okay. So, okay, yeah, so now we've got the key. Okay, so this is where I need to do some more things on the server before I can dive into the example of as they have it. I'm going to need to set up a IP address. It's going to need to be in that same subnet. They're using kind of a weird address here, so I'm not sure what they want to use for that other side. Yeah, I don't see what they want to use for that other side, but let's just go with .183. So that's not the server. This is it. Perfect. Everything's good to go, hopefully. Well, let's see if that's the case. Ping 192.168.199.182. Perfect. Yeah, so everything looks good. So let's set up that public key authentication. So on this server, we're going to do cat.ssh.id_rsa.pub. Oops. ID, not IP. There we go. So we got this giant key. We're going to have to find a way to copy this over. I'm not sure how we can really do that. Maybe if we can set up a FTP. or maybe if there's a way to copy this. But if we can set up a FTP connection to .182, so FTP 192.168.199.182. So connection refused. We don't have FTP enabled on the other side. But if there's a way to enable that, we can just send this key over FTP. Do we have? I'm not sure if there's a way to do it with. I don't think you can do it with Telnet. Okay, we do have Telnet though enabled. Yeah, I'm not sure if there's a way to send it over a Telnet session. What about SFTP? Sweet. So we have SFTP. We don't have FTP, but we have SFTP. So let's send a file over. Let's send that a copy of that public key file. Let's do. So it's going to be. So, okay, well, I don't see, oh, put, yeah, so upload file. So we're gonna put, and then we've got to specify the file we want to put. So, but let's copy that file out so that we're not accidentally, because I'm not sure if it's going to take that file away and put it on there, or if it's going to just put a copy of that file on there. But let's just see if it does that. It won't be a big deal if it takes it away. Okay, now hopefully we can name, yeah, we can name what we want it to be there. So we can be, let's see here, public key for you. Oops, we got no such file or directory. ID.r, oh, is it a dash? No, it is an underscore, remember that. ID RSA.pub. Well, I mean, we do have that, right? Cat. Yeah, we do have that. So why is it saying we don't have that? Because it's saying that local, and then you don't have to specify the remote. Why is it saying I don't have a file that I have? Okay, well, I mean, I have that file. It's very clear that I do. So why does it say I don't have a file that I have? So one reason for that could be that it can't see files that aren't in a particular directory. So hopefully there's a way I can tell which directory. Aha, here we go. So here's display remote working directory, PWD. So that's just a home. What about my local working directory? But even then, I put in an absolute file path, so I don't know why it can't use that. No such file or directory. Well, what the heck? So Oh, change local directory? Maybe, yeah, LCD. There we go. Now we might be able to get it to work. Perfect. So we uploaded this file to the other device. Now we're going to see a id.pub in the home directory instead of just that hidden SSH directory. That dot in front of the directory name just means that it's a hidden directory. So we're going to see another one of those. Yep, so there it is right there. So now we can copy or we can move this into a authorized keys folder in that hidden directory. Oops. Yep. So now we've got here, so we can make a new one, mkdir authorized keys. Oh, actually, never mind. It's going to be a file. So, yeah. So let's print out that. Oops. Bring up the terminal again, and then let's print out that key. So now we've got a clipboard, so we can copy it and we can paste it, but we'll do that in the authorized key file. And we're good. Nice and easy. So, of course, we're going to need to do it on this side as well. We're going to need to open the terminal again, but then do a SFTP to that other side. This side is, I'm going to check because I forget which side this is. This is, oh God, this seems so long. So let's see what, okay, it's ENS6, so let's do a ifconfig ENS6. Okay, so this is 182, so let's open a connection to 183. SFTP 192.168.199.183. Yep, we'll accept the fingerprints. All right, so now we got to change our local working directory, I think, or what was it again? It was like LCD. That's such a strange thing for it to be called. Change local directory. Why isn't it CLD? Oh, okay, whatever. Oh, that's the kind of thing that drives me insane. But all right, so LCD. Yeah, it just drives me crazy because it's like it's hard enough to learn this stuff as is when it's not named like perfect. But you know, I understand like maybe LCD is for something else, or sorry, CLD is for something else, or just you know, once you know more, LCD might be the best possible thing to have chosen. So who am I to judge? Perfect. So we got that again. Let's clean up the extra file on here, idrsa.pub. This is the one that came over from the other side. We know that because it's in the home directory. Of course, we still have our public key that belongs to ourselves, not to the other side in our SSH directory. This is what I was worried about. I thought it might have just sent the file and not sent a copy of the file, but sure enough, it just sends a copy of the file. So let's go over to the other side and put that in our authorized key file. So there it is. We received it just fine. cd.ss. So let's print it out. Cat id rsa.pub. and then copy the key. Copy. And now move into the SSH hidden directory and create a new authorized keys file. Oops, and I don't want to go into insert mode yet. I want to set paste mode. Now I'll go to insert mode with an emphasis on pasting. Perfect. Now I can go back and I won't need this ID rsa.pub file anymore. So now if I SSH to GNS3 at 192.168.199.182, I'm in. I don't need any authentication. Nice and easy. Okay, so now that we've got that set up, let's continue on with the exercise. So, yep, we did all that. Paste it to your, yep, we did all that. Now, you are now ready to use Paramiku to manage the remote host. Notice in this example, we'll be doing the thing we told you not to do because this book is well overdue for a second strike, but I'm generally not somebody who likes to give out strikes, so I will not give it a strike. Okay, so IPF config. For anyone who hasn't heard about what it means to have a strike, 3 strikes, it's out. I'll stop using it to learn. Okay, so yeah, this one's going to be setting up to 192. Yep, so let's use this Ubuntu server to run these commands on. That other one is not the one being referenced here. So let's shrink this down. Perfect. Yeah, that's fine. Okay. And then I'll, of course, need to, this one I won't need up anymore for a while, but this one I will. So let's open up that. Oh, we don't have a virtual environment on here anymore. Let's create one. Python 3 VNV VNV. No such file or directory. I think it's got to be Python 3-m VNV VNV. Oh, we don't have it, so let's do apt get install Python 3-VNV. We got to do a sudo on that. And I have a feeling we don't have internet connectivity. Oh, we do. Okay, sweet. That's actually kind of surprising to me. Oh, no, we don't, because we're not hooked up to that cloud. Yeah, network is unreachable. So let's just do this. Let's unplug this one from the network for now. Delete, and then let's plug this one into the network. All right, and now let's see if we've got connectivity now. We do. So let's install that ability to have virtual environments. Perfect. Let's make a virtual environment. Perfect. Oh, not perfect. Oh, what happened? So sudo apt get install Python 3 VNV. Unable to fetch some archives. Maybe run update. Yeah, I'll try that. Sudo apt get update. Oh, it's going to take a while to update, looks like. Lots of updates. All right, let's try that command again now. All right, this looks a lot better. It's actually incrementing progress now. Yeah, I mean, this is the perfect example, as I keep saying, kind of the running theme of this video series. It's a unicorn environment that they're expecting. Like, you can see I had sudo, you know, right there. You're not going to have sudo in production. It's going to give you sudo. And then, yeah, and the other thing that's going to go very, very wrong for you is when you do that apt-get update, there's something called a PyPy repository that it pulls from. You will not have access to the same PyPy repository that just anyone has access to. Most likely, you will have access to a custom PyPy repository that is managed by somebody, and good luck getting the things you need. All right, so Python, gem, VNV, VNV. Okay, so, oh, right, Python 3 -m, VNV, VNV, -m standing for module. Okay, our journey has come to a close. I guess it's the journey that counts, not the destination, but I don't know if I agree with that in this case. I am glad to be done. So let's set that link back to where it's gonna ultimately need to go. Well, let's just leave it here for now, actually, because I don't know if we're going to be done doing this. Oh, yeah. And we still have to install Paramiku itself. So we still need internet access on this host. So Python 3, import Paramiku. See, we don't have it. So quit. Python 3-m pip install Paramiku, and you don't need the Python 3-m for if you're in a unicorn environment. But if you're not in a unicorn environment, Python 3-m can allow you to use pimp where you would have had trouble doing it otherwise. And for me, it makes more logical sense. It's like, yeah, I'm using a Python module named pip, you know, just like I was using a Python module named VNV. So why would I say I'm not using a Python module? Like, how much time am I really saving by just not typing Python 3-m? And you know, it's like saying, I don't know, it's like leaving off the please and thank yous. You don't have to do it, but it's nice if you do. Or opposite the way around. Okay, so import Paramiku. Perfect. This, I think, is a bit small. There we go. Okay. Oh, I get it. They wanted you to do it using actual Paramiku like that. Okay, well. Oh, it's not going to be that for me. It's going to be GNS3. Oops, and I named that K instead of key. So I'll just do key equals K, just so that I don't have to rerun that command. All right, so now client equals Paramiku.ssh client. And one thing I can even do is, well, actually, no, I can't do that. Well, can I? No, I can't. I was thinking I could delete the variable K and just keep the variable key, but if I delete K, key is that. There's just two things pointing to the actual same thing. So if I delete one of those things, it will delete the actual thing and not just the reference to that thing, I think, is how it works. It might not work that way. It'd be an interesting thing to check, and you know what? I think I'm going to, but not with the Paramiku module added in for extra complexity. There's no reason to test a concept like that when you've got all this extra complexity built around it. Perfect. So everything's working great. Yeah, it's just a lot of output to pull back. We're pulling back the whole everything that's in the home directory. So I've got a few things in there now. So now they want, what else do they want to do? PWD is the next command they want. So it kind of props for this book, definitely. I think not deserving of a second strike yet. And a big reason for that is they've talked about this public key authentication, which is really going to be your best bet for remote management of devices, because not only is it one of the most secure ways to connect, it's also one of the most convenient ways for you to connect, because you no longer need password authentication. You disable password authentication. Sweet. So yeah, we can see ours is different from theirs because they have a different name for their home directory. Perfect. So notice that in the server example, we do not need to create an interactive session to execute multiple commands. You can now, what? Why didn't we need to do that? I didn't notice that, but now that they mention it, that's weird. And they're seriously just not going to explain why we don't need to do that anymore. You can now turn off password-based authentication in your remote host's SSH configuration for a more secure key-based authentication with automation enabled. So you don't even have to have the ability for the server to accept the password configured. You can just have the keys you want to access it be the only ones that get access, and then the users of those boxes have an easy day. So it's just a win-win situation. It's more secure and it's more convenient and usable. Some network devices such as Cumulus and Vayada switches also support key-based authentication, and Juniper VMX is supported too. It's wonderful. It's kind of a pain to paste the key in there, but it does. Let's see if the Cisco ones support it. So I think a way to check that would be configure terminal, of course, and then how about username test, and then so here we can see we've got password, we've got secret, but is there anything like key, public key? Do I see anything like that there? So I see no password, so that's kind of a good clue that there might be something like that, because either it just automatically lets you in if you enable that, or it prevents it from prompting you for a password and you have to have a public key. But it looks like it just automatically lets you in. This is an older device, so some of those modern security best practices are probably not even implementable on a device this old. So yeah, and then secret, that's just going to be a encrypted or plain text string, just like passwords. So yeah, it looks like these old Cisco devices don't have that capability, unfortunately. All right, moving on. So somehow we got skipped ahead way over to chapter 7. This is what those bookmarks are for. Yeah, we got skipped ahead to 46% finished. But we're way back here. We're only like 12%, 13% finished now. Yeah, so this is where we are. Let's update our bookmark in case that happens again. Oops. All right, putting things together for Paramiku. We are almost at the end of the chapter. In the last section, let's make the Paramiku program more usable. There is one downside of our existing script. We need to open up the script every time we want to add or delete a host, or whenever we need to change the commands we want to execute on the remote host. This is due to the fact that both the host and command information are statically entered inside of the script. Hard coding the host and command has a higher chance of making mistakes. Besides, if you were to pass on the script to colleagues, they might not feel comfortable working in Python, Paramiku, or Linux. By making both the host and command files be read in as parameters for the script, we can eliminate some of these concerns. Users and a future you can simply modify these text files when you need to make host or command changes. We have incorporated the change in the script name chapter2_4.py. Instead of hard coding the commands, we broke the commands into separate commands.txt files into a separate file. Up to this point, we have been using show commands. In this example, we will make configuration changes. In particular, we will change the logging buffer size to 30,000 bytes. So that's how we'll be doing that. This, yeah. So these are the commands in that. So let's switch. Let's close this this server. This was just to demonstrate public key authentication too. So I don't think we'll be going back to that, but I won't delete it for now, just in case we need it later. I will switch over this link though. And then I will open up here and we'll go to that GitHub repository that we downloaded and look at the code for making this Paramiku library more usable. Oops, chapter 2, chapter 02. So yeah, here's that commands file. Let's print that out, make sure it's the same. Yep, so this T is just because this terminal window isn't expanded all the way. So let's shrink this down. There we go, perfect. Oh, actually not perfect, still gotta be shrunk down again. There we go. So there, everything looks good. Yeah, and this is really powerful stuff because, you know, as they mentioned, not all your coworkers might be familiar with Python, Linux, anything like that, but they might be really good, competent network engineers used to pasting in stuff into the box and stuff. So you can just have them work on this file, and they'll let you know what needs to go in those boxes. They'll put it in that file, get it all ready to go, and they'll do a great job on configuring the device. But where they would have done a great job of configuring one device, they're not going to do a great job of configuring 10,000 devices. So lots of power behind even this simple early stuff they're introducing us to. All right, so let's do, let's see here. So the devices information is written into a devices.json file. We chose JSON format for the devices information because the JSON data can be easily translated into a Python dictionary, into Python dictionary data types Okay, let's look at that devices.json. Yep, so I'll show you how they're going to do that. I'm not sure which, I think it's chapter 2.4. Chapter 2_4. Oops, and I'll do a pipe plus. So, yep, they're importing this JSON library here. So then they're going to pull in that file, which is going to be, oh, it looks like, oh, cool. It looks like they did a version of that function I was talking about that I had to write. It looks like they're going to talk about that and get that to work. They did this if conditional there. I mean, mine's more like in production. I'd be using mine, not theirs, because mine I think is more reliable. But just the fact that they knew to have that in there is kind of impressive to me. Let's see here. So we should see JSON listed somewhere. I'm gonna use vi so that I can search. So in vi to search, it's a /. So there's JSON showing up once. So then you just do another /. Okay, here we go. So aha, perfect. JSON.load. So what JSON.load does is it converts it from, if it's in a valid JSON syntax, it will convert that to a Python dictionary object. All right, so we are good to go. So yeah, with the script, we've made the following changes. Open devices.json, R as F, yeah, so this is what they're talking about. With open as F, f.readLines. So read lines gives you back a list of each line in the file. Here's an abbreviated output from the script execution. Okay, so let's run this bad boy, and let's, before we do that, alter that devices.json so that the IP addressing is correct. All right, and now let's give it a run. It looks like our virtual environment is no longer running. Yeah, so I'm not sure what happened there. Oh, right, it's gonna be bin in Linux. In Windows, it's scripts. Okay, so now we're gonna do CD mastering Python, chapter 02, Python, chapter 2_4. Gotta give it our username. Gotta give it our password. Oh, it looks like we got a failure here. Oh, we can't connect to the, well, that's funny. I don't know why we can't connect to that one. Okay, we can ping it. Well, can we SSH into it? We can't. So I'm not sure what happened there. I guess I'll try looking at the public key. There might be an issue there. Show IP SSH. Yep, so there's no key again. I'm not sure what happened there. I remember creating one. So crypto key generates. Oh. Okay, finally it's done. Maybe because I didn't save it or something, I don't know. Oh, but now we've got to fix this part up. So copy, paste. Yes. Oops. Hope it'll give me another chance. It will. And you'll notice how ugly this is. That's because in this banner message, it was pasted in incorrectly. So I want to clean that up because that's just too ugly for me. So I'll show you the difference here. In this one, we've got, let's see here. So, oh, huh, I guess I'm not sure why that one is so different because they all have the control C at the end. I thought these would have a control C on a new line and then that one would not, but yeah, so, well, I'm not going to investigate in that. That's really not worth the time. So, yeah, let's run that script again. Yeah, and you can see how messy this is. It's really kind of hard to get right. It takes a lot of skill to use network automation for configuration purposes in a production environment. I will do a sick brag and say that I successfully did it on about 25,000 devices, maybe more, definitely not less. On my list of devices to go after, there were 33,000, but due to DNS issues, due to all sorts of different kinds of issues, some were just stale IPs that were no longer on the network. I did not end up changing all 33,000. But yeah, let's, so it looks perfect. So let's move on. Do a quick check to make sure the change has taken place in both running config and startup config. All right, so let's do that on device R2 because it's going to target both of them. So show run, pipe include logging, and show start pipe include logging. Yep, we got it. Got it. All right, so moving on to the router 1 to check that. Show run, pipe include logging, show start, pipe include logging. And you can even see on here, we've got a nice console message saying that the Ubuntu server did successfully configure it. All right, the Paramiku library is a general purpose library that is intended for working with interactive command line programs for network management. There is another library, NetMiko, that is a fork from Paramiku that is purpose built for network device management. We will take a look at it in the upcoming section. So what I want to say before we move on, just that one section of Paramiku, you can see how much power you've got. And you're going to run into issues, yeah, where you can't pull down enough data, but I'll leave that to you to figure out. I mean, you can go, it's just blog.grandposh.com, and you can find my blog post on there that says how I overcame it. Yeah, like it's even right now, we're 14% of the way done with this book. We've learned about Paramiku. You have more power than you could imagine right now, and more knowledge than most people who have been working as network engineers for multiple years. So yeah, put it to good use. I've done a number of things with just this basically amount of knowledge. I've created a script that allowed people to configure remote systems without having user accounts on them, which was important because for a system like Cisco ACS, where you have all your user credentials and everything like that, you wouldn't want a contractor to just get in there and have high-level permissions on there, or any level of permissions on there. But you can just set up a script that is secure and safe for them to run, and then they just run that script, and everything's all set. And then, of course, the project I mentioned before, I changed the ACLs on like 2,500 devices. So you have just so much power at your hands with just this little bit of information. It's really something that is kind of crazy to think about. But I have a lot of high hopes for the rest of this book. This is where I think I'm going to be learning new things. So let's move right on. The Paramiku library. Sorry, the NetMiko library. Paramiku is a great library to do low-level interactions with Cisco iOS and other vendor devices. But if you have noticed from previous examples, we are repeating many of the same steps between iOS v-1 and iOS ISOV/2, typo, it doesn't count to a strike though. For device login and execution, once we start to develop more automation commands, we also start to repeat ourselves to capture outputs and format them into a usable format. Wouldn't it be great if somebody could write a Python library that simplifies these low-level steps and share it with other network engineers? Ever since 2014, when I was in networking school, Kirk Byers has been working on open source initiatives to simplify the management of network devices. In this section, you will take a look at an example of the NetMiko library that he created. First, we will install the NetMiko library using pip install NetMiko. Let's do that right now. We can use the example published on Kirk's website and apply it to our labs. We will start by importing the library and its connect handler class. Then we will define our device parameter as a Python dictionary and pass it to the connect handler. Notice that we are defining a device underscore type of Cisco underscore iOS in the device parameter. All right, so hopefully that is installed by now. We can continue on. It is perfect. Oh, no, it isn't. Invalid command wheel. Okay, I don't know what that means. But it says it's successfully installed, so hopefully we won't have any issues. Let's go into Python 3 and try to import it. Perfect. All right, so let's, so we can see a special syntax here. This means that you're passing this a dictionary. Let's take a look at the help for Connect Handler. So this help menu was written by Kirk Byers himself. Yep, and we can see it accepts arguments or keyword arguments. So it's a factory function. So factory function selects the proper class and creates objects based on device_type. So I kind of wish it had more information than that, because how do we know that it accepts device_type? How do we know it accepts host username? It doesn't tell you that if you go into the help. All right, so net connect equals connect handler was E1. This is where the simplification begins. Notice that the library automatically determines the device prompt as well as formatting the returned output from the show command. Perfect, and I got it right. Sweet, so you can see really beautiful output. It looks exactly as it would look on the command. We didn't have to do any special code ourselves because Kirk Byers did it for us. Of course, we could add in stuff to our Paramiku and just do that ourselves, as I have done in my projects. But why not just let Kirk Byers do the work? What is it? Yeah, 6 years ago. We'll let 6 years old younger Kirk Byers do this work for us. Take advantage of that and use our extra time to make videos on network automation and JNCIE SP. All right, notice that we are defining, so yep, we already got there. Let's see another example for the second Cisco iOS device in our lab, but this time we will define the iOS v-2 parameter when we initiate the connect handler object and send a configuration command instead of a show command. Note that the command attribute is a list that can contain multiple commands. So one thing I'm planning to do for this job on the 25th is for any network automation stuff they want me to do. This was a part of the interview process, so they will want me to do something. I'm going to use the Paramiku module from now on. I'm going to give up using Paramiku on its own. But what I'm going to do is a pull request from Kirk's repo, and I'm going to put that on my work computer. Hopefully, if I can, if not, I'll just do whatever whatever the plan is. Of course, I will follow, but ideally, in a unicorn environment, if this happens to be one, hopefully it is. But it is what it is. I'm really happy to have it. But if it were a unicorn environment, I'd be able to do a pull request on Kirk Byers' NetMiko code and then use it for my own purposes. And if I see anything that I would like to change or that works better than what he has, I would submit that as a push request up to his repository. And then he would credit me, and I'd be able to tell people at cocktail parties that I have contributed to the NetMiko code and I have actual commits pushed up and accepted by Kirk Byers. That is something that definitely appeals to me, having that sort of those bragging rights. So in order to get those bragging rights, you have to be using the code for one, and you have to have something worth contributing to it for two, which are pretty big steps. Okay, so let's see another example for the second. Okay, so yeah, let's do it. Oops, it's a bit too small. I can't see it though if it's not any. Oh, there we go, now I can see it. Oops. Oh, no, this is gonna be fine. Oh, connection to the device timed out. So that's too bad. Oh, right. But it's understandable because we're using a different IP than they're using. So I just need to change this to a 2 and it will be all good to go. There we go. Moving on. So output equals net connect to dot send config set. Look at that. Look at how pretty that is. That's exactly. Oh yeah. I really like how it shows you what you sent too. So it sent config term. That's the abbreviation you use for configure terminal. And then enter configuration commands 1 per line and with Control Z. Yeah. So look at how clean and tidy that is. That's really wonderful. Thank you, 6 years old younger Kirk. I wonder what present day Kirk has to offer. I think this Nornir framework is probably it. So let's exit out of this and read the rest. The NetMiko community is a great time saver and is used by many engineers. In the next section, we will take a look at the Nornir framework, which aims to simplify low-level interactions. So yeah, NetMiko is great. I like it. I love it. I want some more of it. So next automation project I have, I'm going to be ditching just plain old bare bones Paramiku, doing a pull request on NetMiko, and anything I see needs improvement, anything I can add, I'll be doing a push, and hopefully I can get some, because it's an open source collaborative thing, hopefully I can get my commit reviewed and accepted, and say that I contributed to this wonderful thing that everyone loves. The Nornir framework. Nornir is a pure Python automation framework intended to be used directly from Python. We will discuss another automation framework written in Python, Ansible, in chapter 3. The Python automation framework, Ansible Basics, and chapter 5, the Python automation framework beyond basics. I wanted to introduce the framework in this chapter as a way to demonstrate another way to automate devices with low-level interaction. However, if you are just starting out on the automation journey, the framework might make more sense after you have finished reading chapter 5, the Python automation framework beyond basics. Please feel free to scan through the example and come back to it later. Of course, we will start with installing Nornir in our environment. All right, let's do that. Pip install Nornir. Nornir expects us to define an inventory file, hosts.yaml, consisting of the device information in a YAML format. The information specified in this file is no different than what we have previously defined using the Python dictionary in the NetMiko example. So yeah, that's kind of nice. Seems like it'd be easier to kind of automate that than the other way. So I might not be using NetMiko actually. I might just be going straight to Nornir. Okay, but we're going to need to edit that file. So before reading on, I'll wait for it to finish downloading, and then I'll go make the modifications to that file. It looks like it's failing a bunch of stuff, but hopefully that won't make a difference. Okay, well, we're all done. So this is going to be hosts.yaml. I don't see where this is, but I can do a find dash name. Hosts.yml. Okay, so I found it here. So let's edit that. Oops. Okay, let's just move into that. Chapter 02, and now via host.yml. Oh, I'm kind of confused why this is empty. I'm not sure where they. So we can use the NetMiko plugin from the Nornir library to interact with our device, as illustrated in the chapter 2_5 file. Yeah, let's just so from Nornir input init Nornir. Let me go send commands. Yeah, already Nornir is kind of a bit too difficult. I'd rather just define that dictionary. I mean, that's to me easier than using a separate language, especially one that I'm not sure what YAML is. Yet another markup language, I know stands for that, but I don't understand what advantage there is to using a different language and not just sticking with Python. So let's do a find dash name, and then we'll do Nornir. Okay, and now let's move into that. Oh, I probably need the dot. There we go. Now maybe the hosts file is here. I'm not sure where that host file is. Well, actually, we've only got one host file. Yep, so we've only got one there. Yeah, let's move into that though. All right, and let's just build out that file. I'm not sure what the deal with it is, but. Oh, okay, so now it's working. Why can't it, doesn't it work when I do a vi? It does, okay, so, okay. And this has gotta be .2. Okay, so we edited that. So now we can use the NetMiko plugin from the Nornir library to interact with the device. So let's give this a shot. From Nornir, import init Nornir. Hopefully that works. It does. From Nornir.plugins.tasks.networking. Import NetMiko send command from plugins.functions.text import results and r equals init Nornir results equals nr.run. Ooh, and here you can see they're using that special syntax that is required if you want to contribute to the requests library that I prefer. Look at that. Look at how pretty that is. I like that. I really like that. Let's try to make it a little bit more clear. Look at how pretty that is. I really like that. So we've got NetMiko send command, and then iOS changed equals false. And then we've got the send command. Oh, okay. So now we've got the NetMiko send command, and we've got the results of it. And then that's the end. Then we've got it for the second one. So look at that, really nice. In that output too, there's really easy searching you can use using data analysis in Python. You can search through that really easy. Yeah, super nice. Good job, Older Kirk. The execution output is shown as follows. Oh yeah, let's try just executing the whole thing. Yep, so we got the same thing we had there. It's just running in a script instead of run on the CLI. There are other plugins in Nornir besides NetMiko, such as the popular Napalm library. Please feel free to check out Nornir's project page for the latest plugins. We'll discuss another automation framework, PyATS and Genie, in Chapter 15, Test-Driven Development for Networks, when we discuss testing and verification, which sounds really interesting. I think this book is kind of starting to take off. We have taken a pretty huge leap forward in this chapter in automating our network using Python. However, some of the methods we have used feel like workarounds for automation. We attempted to trick the remote devices into thinking they were interacting with a human on the other end. Even if we use libraries such as NetMiko or the Nornir framework, the underlying approach remains the same. Just because somebody else has done the work to help abstract the grunt work of the low-level interaction, we are still susceptible to the downsides of dealing with CLI-only devices. Going ahead, let us discuss some of the downsides of pexpect and Paramiku compared to other tools in preparation for our discussion on API-driven methods in the next chapters. Downsides of pexpect and Paramiku compared to other tools. The biggest downside of our method for automating LI-only devices so far is that the remote devices do not return structured data. They return data that is ideal for fitting on a terminal to be interpreted by a human, not by a computer program. The human eye can easily interpret a space while a computer only sees a return character. We will take a look at a better way in the upcoming chapter. As a prelude to chapter 3, APIs and intent-driven networking, let's discuss the idea of idempotency. So my understanding of idempotency before we go on, because I want to make sure that my understanding is correct, is that something is idempotent when it changes its config only if it has a need to. If you send it a command and it executes that command, even though it has already executed it previously and does not need to execute it, and it still executes it, it is not idempotent. So an idempotent, the idea of idempotency is having your network smart enough to know whether or not the changes you send to it are required at the time they are sent. Idempotent network device interaction. The term idempotency has different meanings depending on its context, but in this book's context, the term means that when a client makes the same call to a remote device, the result should always be the same. I believe we can all agree that this is necessary. Imagine a scenario where each time you execute the same script, you get a different result back. I find that scenario very scary. How can you trust your script if that is the case? It would render our automation effort useless because we need to be prepared to handle different returns. Since pexpect and Paramiku are blasting out a series of commands interactively, the chance of having a non-idempotent interaction is higher. So going back to the fact that the return result needed to be screen scraped for useful elements, the risk of difference is much higher. Something on the remote end might have changed between the time we wrote the script and the time when the script is executed for the 100th time. For example, if the vendor makes a screen output change between releases without us updating the script might break. If we need to rely on the script for production, we need the script to be idempotent as much as possible. Okay, so it's a little bit different from what I thought. Their definition of idempotency that they're going to be using for this book, and as they mentioned, there can be many definitions for it, is something where any call you make to a remote device, the result is always the same. So if something is idempotent, you would never send something to that device and get something back, send something to the device again and get something back that was different from what you got back the first time. That would never happen if it was idempotent. And we can see in the interactions we did earlier, they were obviously not idempotent, because if you send the show version command, but you don't clear the buffer, you send it again, it depends on if that buffer is cleared or not. You're going to get back different things every time. So when you send something, what you get back isn't guaranteed and isn't always what you would expect. That kind of configuration is not idempotent. All right. So, yeah, how can you trust your script? So imagine a scenario where you execute the same script, you get a different result back. I find that scenario very scary. How can you trust your script if that is the case? It would render our automation effort useless because we need to be prepared to handle different returns. Since pexpect and Paramiku are blasting out a series of commands interactively, the chance of having a non-idempotent interaction is higher. Going back to the fact that the return results needed to be screen scraped for useful elements, the risk of difference is much higher. Something on the remote end might have changed between the time we wrote the script and the time when the script is executed for the 100th time. For example, if the vendor makes a screen output change between releases without us updating the script, which they won't. I mean, it said earlier in the book, in 20 years, they didn't make any changes like that. The script might break. If we need to rely on the script for production, we need the script to be idempotent as much as possible. Bad automation speeds bad things up. Bad automation allows you to poke yourself in the eye a lot faster. It is as simple as that. Computers are much faster at executing tasks than us human engineers. If we had the same set of operating procedures executed by a human versus a script, the script would finish faster than humans, sometimes without the benefit of having a solid feedback loop between procedures. The internet is full of horror stories of when someone pressed the enter key and immediately regretted it. I've never been there too badly, but I definitely know what they're talking about. And I have had that feeling of enter horror. We need to make sure the chances of bad automation scripts screwing things up are as small as possible. We all make mistakes. Carefully testing your script before any production work and having a small blast radius are two keys to making sure you can catch your mistake before it comes back and bites you. No tool or human can eliminate mistakes completely, but we can strive to minimize the mistakes. As we have seen, as great as some of the libraries we have used in this chapter are, the underlying CLI-based method is inherently faulty and error-prone. We will introduce the API-driven method in the next chapter, which addresses some of the CLI-driven management deficiencies. Summary: in this chapter, we covered low-level ways to communicate directly with network devices, and we saw how powerful they can be. Without a way to programmatically communicate and make changes to network devices, there is no automation. We looked at two libraries in Python that allow us to manage devices that were meant to be managed by the CLI. Although useful, it is easy to see how the process can be somewhat fragile. This is mostly due to the fact that the network gear in question was meant to be managed by human beings and not computers. In Chapter 3, APIs and Intent-Driven Networking, we will look at network devices supporting API and network-driven networking. And right there, that's assuming in a unicorn environment again. So you might, come away from that chapter thinking, oh, that's silly. Why would you ever use something that is for something meant to be managed by human beings and not computers? Why would you use a computer to manage that? Just use the features on it that allow it to be managed by computers. Well, I mean, some of these might not have those features, unless we're talking about SNMP. I really hope they do talk a lot about SNMP, because that would be awesome. I'm not sure what they mean right now by API and intent-driven networking. I don't think they're talking about SNMP, but if they are, I will be very impressed and very excited to see what this book is saying. So let's just keep moving on and find out what they're talking about. APIs and intent-driven networking. In chapter 2, low-level network device interactions, we looked at ways to interact with the network devices using pexpect and Paramiku. Both of these tools use a persistent session that simulates a user typing in commands as if they are sitting in front of a terminal. This works fine up to a point. It is easy enough to send commands over for execution on a device and capture the output. However, when the output becomes more than a few lines of characters, it becomes difficult for a computer program to interpret the output. The returned output from pexpect and Paramiku is a series of characters meant to be read by a human being. The structure of the output consists of lines and spaces that are human-friendly but difficult to be understood by computer programs. In order for our computer programs to automate many of the tasks we want to perform, we need to interpret the returned results and make follow-up actions based on the returned results. When we cannot accurately and predictably interpret the returned results, we cannot execute the next command with confidence. Luckily, this problem was solved by the internet community. Imagine the difference between a computer and a human being when they are both reading a web page. The human sees words, pictures, and spaces interpreted by the browser. The computer sees raw HTML code, Unicode characters, and binary files. The computer sees a lot more than what the human sees. What happens when a website needs to become a web service for another computer? The same web resources need to accommodate both human clients and other computer programs. Doesn't this problem sound familiar to the one that we presented before? The answer is the Application Program Interface, API. It is important to note that an API is a concept and not a particular technology or framework. According to Wikipedia, in computer programming, an application programming interface, API, is a set of subroutine definitions, protocols, and tools for building application software. In general terms, it's a set of clearly defined methods of communication between various software components. A good API makes it easier to develop a computer program by providing all the building blocks, which are then put together by the programmer. In our use case, the set of clearly defined methods of communication would be between our Python program and the destination device. The APIs from our network devices provide a separate interface for computer programs. The exact API implementation is vendor specific. One vendor will prefer XML, while another might use JSON. Some might provide HTTPS as the underlying transport protocol, and others might provide Python libraries as wrappers. We will see examples of each in this chapter. Despite the differences, the idea of an API remains the same. It is a communication method optimized for other computer programs. In this chapter, we will look at the following topics: treating infrastructure as code, IAC, intent-driven networking and data modeling, Cisco NX API and the application-centric infrastructure, ACI, Juniper Network Configuration Protocol, NetConf, and PyEZ, Arista E API and PyE API. We will start by examining why we want to treat infrastructure as code. So this is where I start to get a little skeptical, because yeah, this stuff is all wonderful and great, but it's things that they are trying to sell you. And I'm not necessarily 100% sold on it. Of course, I'm hoping to be by the end of this book. And then of course, we get into those problems with unicorn environments where, okay, great, if your whole network runs Cisco NX API, you're all set, but what if only half your network runs that? What if none of your network runs that? You know, what are you going to do? Are you just going to have to rely on NetMiko and Nornir stuff, or can you use infrastructure as code and intent-driven networking and data modeling if you don't have an ACI, netconf, or Pi API. All right, so infrastructure as code. In a perfect world, network engineers and architects who design and manage networks should focus on what they want the network to achieve instead of the device level interactions. But we all know the world is far from perfect. Many years ago, when I worked as an intern for a second-tier ISP, wide-eyed and excited, one of my first assignments was to install a router on a customer's site to turn up their fractional frame relay link. Remember those? How would I do that? I asked. I was handed down a standard operating procedure for turning up frame relay links. I went to the customer's site, blindly typed in the commands, looked at the green lights flashing, and then happily packed my bag and patted myself on the back for a job well done. As exciting as that assignment was, I did not fully understand what I was doing. I was simply following instructions without thinking about the implication of the commands I was typing in. How would I troubleshoot something if the light was red instead of green? I think I would have called the office and cried for help. Tears optional. Of course, network engineering is not about typing in commands into a device, but it is about building a way that allows services to be delivered from one point to another with as little friction as possible. The commands we have to use and the output that we have to interpret are merely means to an end. In other words, we should be focused on our intent for the network. What we want our network to achieve is much more important than the command syntax we use to get the device to do what we want it to do. If we further abstract that idea of describing our intent as lines of code, we can potentially describe our whole infrastructure as a particular state. The infrastructure will be described in lines of code with the necessary software or framework to enforce that state. Intent-driven networking. Since the publication of the first edition of this book, the terms intent-based networking, IBN, and intent-driven networking, IDN, have seen an uptick in use after major network vendors chose to use them to describe their next generation devices. Oh, so were those words defined in the first edition of this book? That'd be interesting if they were. It doesn't say. The two terms generally mean the same thing. In my opinion, intent-driven networking is the idea of defining a state that the network should be in and having software code to enforce that state. As an example, if my goal is to block port 80 from being externally accessible, that is how I should declare it as the intention of the network. The underlying software will be responsible for knowing the syntax of configuring and applying the necessary access list on the border router to achieve that goal. Of course, IDN is an idea with no clear answer on the exact implementation. The software we use to enforce our declared intent can be a library, a framework, or a complete package that we purchase from a vendor. In using an API, it is my opinion that it gets us closer to a state of intent-driven networking. In short, because we abstract the layer of a specific command executed on our destination device, we focus on our intent instead of the specific commands. For example, going back to our block port 80 access list example, we might use access list and access group on a Cisco and a filter list on a Juniper. However, using an API, our program can start asking the executor for their intent while masking the kind of physical device the software is talking to. We can even use a higher level declarative framework such as Ansible, which we will cover in Chapter 4, the Python automation framework, Ansible Basics. But for now, let's focus on network APIs. Screen scraping versus API structured output. Imagine a common scenario where we need to log into the network device and make sure all the interfaces on the device are in an up state. Both the status and the protocol are showing as up. For the human network engineers getting into a Cisco NX-OS device, it is simple enough to issue a show IP interface brief command in the terminal to easily tell from the output which interface is up. Let's do that. Oh, and they're doing it on a special device. Let's just do it on this device. Yep, good old classic command. The line break white spaces and the first line of the column title are easily distinguished by the human eye. In fact, they are there to help us line up, say, the IP addresses of each interface from line 1 to line 2 and 3. If we were to put ourselves in the computer's position, all these spaces and line breaks only take us away from the really important output, which is which interfaces are in the up state. To illustrate this point, we can look at the Paramiku output for the same operation. All right, let's do it. Oh, these are keyword arguments, so they have to be specified. Shoot. Host key verify equals false. Okay, shoot, I might need to go back and look up how this goes. I forget exactly. I'll just print out one of the earlier examples. Yep, here it is. So import Paramiku, perfect. Now we're going to do connection equals paramiku.ssh connection dot set missing host policy. Oh, look for keys and allow. Okay. So it's going to be 16.1.20. And then username, Cisco, password, Cisco. False. Sweet. Okay, so now let's see what happens in Paramiku. Oh, and let's do a new connection equals connection dot invoke shell. All right, so new connection send show IP int. And looks like they have the slash going the wrong way. That's an error. You can't have it that way. All right, so yeah, let's see how jumbled and messy that looks. Nowhere near makes that look really, really pretty, but even NetMiko is a huge improvement. And of course, you can clean it up yourself. It doesn't have to look this bad. You have the whole polar of Python behind you, but Kirk Byers did the work for you, so there's no reason for you to do it yourself. Okay. If we were to parse out that data contained in the output variable, here is what I would do in a pseudocode fashion. Pseudocode means a simplified representation of the actual code I would write. To subtract the text into the information I need. Number one, split each line via the line break. Number two, I do not need the first line that contains the executed command of show IP interface brief, and we'll disregard it. And this is kind of funny because this is a lot of what I used to do this whole process. Number three, take out everything in the second line until the VRF and save it in a variable as we want to know which VRF the output is showing. Number four, for the rest of the lines, because we do not know how many interfaces are there, we will use a regular expression statement to search if the line starts with interface names, such as LO for loopback and ETH for ETH interfaces. Number five, we will need to split this line into three sections separated by a space, each consisting of the name of the interface, IP address, and then the interface status. Number six, the interface status will then be split further using the / to give us the protocol link and the admin states. Phew, that is a lot of work just for something that a human being can tell at a glance. And I've done that work, and that's what Kirk Byers has done actually in making NetMiko. You can be able to optimize the code and reduce the number of lines in the code. Oh, you might be able to, But in general, the steps are what we need to do when we need to screen scrape texts that are somewhat unstructured. There are many downsides to this method, but some of the bigger problems that I can see are listed as follows. Scalability. We spent so much time on painstaking details to parse out the outputs from each command. It is hard to imagine how we can do this for the hundreds of commands that we typically run. Predictability. There is really no guarantee that the output stays the same between different software versions, but we have seen that it went unchanged for like 10 years. If the output is changed ever so slightly, it might just render our hard-fought battle of information gathering useless. Vendor and software lock-in. Perhaps the biggest problem is that once we spend all this time parsing the output for this particular vendor and software version, in this case, Cisco NX-OS, we need to repeat this process for the next vendor that we will pick. I don't know about you, but if I were to evaluate a new vendor, the new vendor would be at a severe onboarding disadvantage if I have to rewrite all of the screen scrape code again. So these are all, I think, really valid points, but I don't think these are arguments not to do this. Yes, there are arguments to pick a better way if you have a better way available. But if this is all you can do, you can provide such insane, crazy value, unimaginable value to your network just by doing this sort of thing that I'm actually kind of concerned that this author is saying that if you can't take advantage of these sorts of improvements, it's not worth doing automation, network automation at all. I would completely disagree with that. Even this whole step process here, and even all this painstaking details, all that, it's going to just make things unimaginably better. And yeah, like things will break. What do I mean? Of course, number one, do no harm. But remember, from the beginning of this book, we're going to be focusing on real world, or sorry, read-only simple tasks in the real world that don't have the capability of doing harm. But I'm just worried that this book is saying that because that kind of network automation is not as scalable, not as predictable, is tied to a particular device or software version, that it's not worth doing. I would say, in my personal opinion, the things I have done, the things I have seen, it's just, for me, mind-blowing what even simple basic skills in that sort of thing can do. And I think just because you can't graduate from Harvard with a PhD and a 4.0 doesn't mean you shouldn't go to school. Let's compare that with an output from an NX-API call for the same show IP interface brief command. We will go over the specifics of getting this output from the device later in this chapter. But what is important here is to compare the following output to the previous screen scraping command. So yep, nice and pretty. It's just a, looks like it's it's neither a Python dictionary nor a JSON object, because this, well, actually no, this is a string. So yeah, it looks like it's a Python dictionary. We'll be able to tell if there's a Boolean value because they have to be a certain way in a JSON payload or a Python dictionary. It looks like it's JSON though, because that's what they're going to talk about next. NX-API can return output in XML or JSON, and this is the JSON output that we are looking at. Right away, you can see the output is structured and can be mapped directly to the Python dictionary data structure. So this is another good example on why it's important to use the right language. If you call this Python, you won't know that you have to take the extra step and use the Well, actually, you might not even need to do that. Like if it's in the exact same syntax as Python, like a Python dictionary, like you can probably just define it as a Python dictionary. But yeah, I mean, I was just saying, like if you call it a JSON payload and it's a Python dictionary, or if you call it a Python dictionary and it's a JSON payload, you might be kind of making things a bit more difficult on yourself because you'd run into those issues where you're using the wrong one, but you could have prevented yourself from getting hung up on that by having a better understanding of what kind of data types you are working with and what you need to do to convert them into the ones that you will need. Right away, you can see that the output is structured and can be mapped directly to the Python dictionary data structure. Once this is converted to parsing required, oh, and my laptop has turned black. The screen has anyway. I don't know if I'm still recording or running or what the issue is. Oh, okay, I'm back. Okay. Once this is converted to a Python dictionary, there's no parsing required. You can simply pick the key and retrieve the value associated with the key. You can also see from the output that there are various metadata in the output, such as the success or failure of the command. If the command fails, there will be a message telling the sender the reason for the failure. You no longer need to keep track of the command the program issued because it is already returned to you in the input field. There is also other useful metadata in the output, such as the NX-API version. This type of exchange makes life easier for both vendors and operators. On the operator side, they can easily transfer configuration and state information. They can add extra fields when the need to expose additional data arises using the same data structure. On the operator side, they can easily ingest the information and build their infrastructure around it. It is generally agreed by all that network automation and programmability is much needed by both network vendors and operators. The questions are usually centered on the format and structure of the automation. As you will see later in this chapter, there are many competing technologies under the umbrella of API. On the transport language alone, we have REST API, netconf, and RESTconf, among others. Ultimately, the overall market might decide about the final data format in the future. In the meantime, each of us can form our own opinions and help drive the industry forward. So I think I'm going to stop here. Yeah, still a lot more to go in this chapter, but my computer just kind of blanked out and I need a break, and I don't want to lose all the work I've done so far just from my computer glitching out. So I'm going to give it a break. I'm going to try to figure out where I left off because what the heck? I don't see where, is this it? No, where was I just reading? So I was looking at, oh, right, because I kind of glossed over that. So I think I think it's right here. So the last, overall, the market might decide. Yeah, so this is where I left off. I'm gonna bookmark this. Sometimes it confuses me that the pages jump from left to right. This used to be the page on the left-hand side. Now it's the page on the right-hand side. But I've got it saved. I'm gonna stop it here, give myself a break, give my computer a break, and I'll see you in the next video. Thanks for watching.